Guys, I remember pretty distinctly yesterday this time feeling the sleepiest I felt all day, so I know how you feel if you feel as I felt yesterday at this time. I actually couldn't ask for a better setup in terms of background for this talk than the previous talk. So I, too, am really excited about abstract syntax tree transformation and all of the consequences that follow from it, but especially how it can be applied to accelerate this time machine that we're in to get us to the future of JavaScript more quickly. So I am Benjamin without the I on most forms of social media. I work at Facebook on our JavaScript infrastructure team, which happens to work on a product called React, which I'm not talking about today, but that's something else that I do. Feel free to follow up with me on any of these afterwards, or find me and we can have a chat. So my talk is about the future of JavaScript. I didn't really know, because I always forget how a title is supposed to be capitalized, so I left everything, except for ECMAScript, which I do know, uncapitalized. Tried to refresh my memory, so I went to Wikipedia and read up on this article on letter case. It turns out there's a whole section here just about headings and publication titles, discussing the wildly divergent history of thought about how you should capitalize your prepositions and the beginning and final words of titles. And it left me more confused than I was when I pulled up this article in the first place. So I just about gave up, but then I kept looking throughout the internet and found this other amazing website called titlecapitalization.com. And this eschews all of the explanation behind what it's going to do and just invites you to paste your title into this text field. And it almost happens too quickly, so watch carefully. Oh no, don't allow. What? Okay. Boom. All right. So apparently easing and beyond are supposed to be capitalized, but into and are not. So we're done. Anyway, so this is a trivial example of something of a more general point that I'd like to make, which is that we have the opportunity as technologists, which is what we all are, to make certain kinds of problems disappear forever. So the problem of title capitalization, I would argue, is solved by titlecapitalization.com. And whether it's title capitalization or automatic memory management or self-driving cars, this is how history is going to judge our efforts as technologists, according to the number of problems that we were able to make disappear from the everyday lives of humanity, and also maybe according to the number of new things that we made possible. All right, so what kind of problems do I like to make disappear? Well, there was a talk yesterday by David Bird about JavaScript memes, where he suggested that you could shorten any code that compares a value with -1 using the bitwise negation operator, the tilde. So if you remember that one weird trick, you would take code like this, which is awfully verbose, and turn it into code like this. And if you're, I'll post these slides later. If you're following along, you'll find that this is actually live editable. So I'm actually just going to get rid of all that cruft so that we're just looking at this and you can see what's happening. I'm parsing the abstract syntax tree and looking for binary operators that are being comparing two operands, one of which is -1. And in that case, I take the other operand and stick a tilde in front of it and get rid of the binary comparison. So you can see that if I go and put this on the other side of the operation, it still works, comes to the same thing. I can even switch this to not double equals, and it still works, or triple equals, and it will negate the resulting expression. So I want you to think for a second about how you might do this with, say, regular expressions, looking for this kind of code and changing it in this way. And while you think about that, I'll just sort of throw a monkey wrench into the situation and suggest that I could put anything I wanted to here in this comma, like a bunch of unclosed parentheses. And I imagine that whatever regular expression you came up with could be thwarted by some amount of junk in that comment, unless you also were actually parsing the code and recognizing the comment as a comment and skipping over it and then operating on the abstract structure of the code itself and doing something similar to what's going on here. So what is exactly going on here? So the routine here is that I use a tool called Recast that I wrote and that we use at Facebook that has some utilities for checking the types of nodes in an abstract syntax tree and also building up new nodes to add to the abstract syntax tree. And then I call recast.parse on a string of code, which gives me a tree. And then I can do whatever I want to that tree. And in this case, I'm going to write this visitor class, which is just one of many abstractions that you can use for visiting an abstract syntax tree and manipulating it. And how does this work? Well, it's going to visit all binary expressions and grab the operator from such nodes, and then check this clever regular expression to see if the operator is either double equals or triple equals or not equals or not double equals, which are all things that we can handle here. And then it'll check each operand to see if it is -1. And this is checking to see if it is the abstract syntax tree node corresponding to -1, which is slightly different from just the numeric value, as you'll see with the implementation of is -1, the helper function. So if the left side is -1, then we care about the right side and vice versa. And if neither one of the operands is -1, we're returning and not doing anything to this part of the AST. All right, so if we pass that, then we know we're dealing with a comparison to -1, and so we're going to binary negate the other node. And then if the operator was equality, we're going to negate the whole expression by adding a bang to the beginning of it. The only thing that remains is to traverse the rest of the tree, because perhaps there are nested expressions that compare against -1, and we want to make sure that we handle those as well. So how would we implement this? Is -1 helper function? Well, as I said, it's not the numeric value -1. It's actually itself a unary expression where the argument is the numeric literal 1, and the operator is a negative sign. So that's an easy bug to make, thinking that you should just be looking for literals whose values are equal to -1, but it's just a slightly more complicated syntax tree node than that. Okay? So what remains? Well, you've modified the abstract syntax tree, but what you probably really want is concrete syntax. Abstract syntax is fine and good, but you can't run it. So you create one of these visitors, and you visit the AST, which modifies it, and then you call recast.print on that AST, and get the code property of the little object that it returns, and that prints out this expression with a tilde in front of it, and no more comparison against -1. All right, so what is this recast thing, and why should you think about using it perhaps instead of burrito or falafel or other tools that exist? So recast, the word, is a word that I chose as the name for this tool. And it makes sense in sort of two ways. First of all, it recursively traverses abstract syntax trees. So rec AST sort of leads to this as a choice of word. But it's also a perfectly valid English verb, which means to melt down some metal and reshape it, or to rearrange something, remodel, or supply with a new cast. So there's also, I don't know, some poetry to it, I guess. I like it. So how do you use it? You require it. It's a node module. It's on NPM. You call recast.parse with a string of source code that gives you an abstract syntax tree, and then you do whatever you want using any tool that you want. You could use ES-traverse if you want. Really, anything goes here. And once you're done, you call recast.print on the same AST, and you get back some code. Now, what's special about this code? How is this different from what other tools give you? Well, it accomplishes something that the author of the Esprima parser has called non-destructive partial source transformation, which is, I think, a good term for reusing parts of your code that you didn't touch in modifying the abstract syntax tree and just copying them over to the result while falling back to a pretty printer in places where you did either create new nodes or do enough damage to the abstract syntax tree that it wasn't able to just directly reuse the original code. So you can write scripts that perform arbitrary transformations on your code and run them over vast code bases, as we have at Facebook, certainly, and get out human-readable diffs that you can actually submit for code review. And this works so well that in my experience at Facebook, a large percentage of the time, people reviewing diffs that I generate with this script don't know that I used a script. It's not apparent, because I'm not just pretty printing the entire file and blowing away all of its idiomatic formatting. I'm actually preserving as much as possible and just changing the parts that matter. So that presents a bit of a moral hazard, right? I could make a living writing these scripts. I could be the laziest, most productive programmer at Facebook, probably. Or, I could be the change I want to see in the world or something. And I'd like to say that I have always taken the Gandhian path here, because, as Agent Smith might say from The Matrix, one of these lives, Mr. Newman, has a future, and the other also has a future. But my confession is that I have given in to that temptation to be lazy. And as a personal anecdote, when I moved to New York and left the team that I was on at Facebook in California, I didn't know what I was going to do. I didn't know what team I was going to join. I was looking around at various projects and figured that I needed to at least appear productive in that time while I wasn't quite sure what to do. And it was at about the same time that we implemented support for writing ECMAScript 6 class syntax. And I wrote up a little script using Recast to translate a bunch of old idioms for defining JavaScript class-like things into the new class syntax, just standardizing everything. And ran this across the entire code base, spitting out diffs like this, which are actually pretty readable. You can see that a large part of this code, even though it was reindented, is not touched by the diff. And so where previously we had a separate constructor function declaration and then this class.extend and copy properties routine on the green side, you can see that tag token function name has become the name of the class, and it extends the thing that was the second argument to class.extend. The body of the tag token constructor function has become the body of the constructor method, and where it was calling this.parent.construct, it's now calling the very pretty super function. And one thing to notice here is that down at the very bottom of this file, and I chose it because this is a relatively small example, it doesn't span too many lines, but all the way down at the bottom, you'll notice that there's a parenthesis and a semicolon that's being removed from the end of that class declaration. And I argue that that would be extremely difficult to identify as something that needed to happen if you were using regular expressions to munge your code. You'd have to do a great deal of manual inspection of this kind of thing, and you wouldn't just know that you were generating well-formed code because you were actually operating on the abstract syntax of that code. So all of this led to a sort of process for translating this kind of code that got more and more reliable and was able to handle more and more of the long tail of edge cases of previous ways of doing this. And it did indeed make me look quite productive for those 6 months or so. All told, ended up changing 1,600 or so files for combined 150,000 insertions and deletions. And I guess you can tell from this that we have about one class per file. 1,658 classes were converted. And today, and this is the really important thing, there are now more than 3,500 classes, new style ECMAScript 6 classes in the code base. And I claim that all of those additional classes, more than twice as many as I originally converted, were written by people who just looked around at the rest of the code base and mimicked the style that they saw, never had to read an internal wiki article or have me tell them anything about ECMAScript 6 classes. They just brought the background that they already had from writing classes in other programming languages and continued doing what seemed to be the way of doing things. So although I'm being a little facetious about the laziness of this process, it was actually really worthwhile because it means that we now have a relatively standard way of writing classes in our JavaScript code base. All right, so I hesitate to mention this because it might make people want to work for Facebook for the wrong reasons, but my development box has 32 cores, and I ran this script using GNU, or GNU Parallel, which managed to take 228 sort of subjective user seconds and do all of that work in just 12 actual wall clock seconds. And so I managed to do, I don't know, if each of those class conversions would have taken maybe 3 or 5 minutes by hand, that's like weeks of mind-numbing person days of work, or person weeks, I guess, that happened in the space of 12 seconds. And so, you know, if you're actually curious about all the details here, I gave a whole talk last month, and these links will take you to both the slides and a video of that talk. But I just want to point out, as an aside, that these numbers should demonstrate why that whole meme of programmer efficiency multiples, you know, the 10x or 100x programmer myth, is just total nonsense. Because if you do the math, we all have our moments of striking productivity and our days where we get almost nothing done. But in those 12 seconds, I was something like a 50,000x programmer. And if I attributed that to my own actual skill, I would be totally deluded. Just imagine if the Facebook code base were a little bit smaller. Well, then my, you know, supposed efficiency relative to someone trying to do this by hand would be, you know, drastically less, and that doesn't actually say anything about me. So if ever someone invokes this notion that there are programmers that are, you know, 10 or 50 or 100 times as productive as other programmers, you should tell them they are an idiot. But I also hope that these numbers demonstrate the power of the right tool to make a difficult problem disappear completely, because it is something to aspire to, these moments of incredible productivity. You just shouldn't attribute it to anything inherently good about yourself. It's sort of the grace of conspiring circumstances that allow you to make those strides forward. All right. So if the moral hazard was that I could make a living writing these scripts and become a hollow shell of a person who just comes into work every morning and, you know, for 5 minutes runs them and submits some diffs to be reviewed, then what is the alternative? Like, what could I do to bring value both to my life and other people's lives? Well, I find it's common in programming that you have this epiphany. You realize that you should have been doing something this one way all along, but it's not the way you've been doing it so far. And that's great. It's always good to know that if you were starting over from scratch, you should do something differently. But it's not quite a complete idea unless you actually have a plan for getting to a place that's as if you had started that way from the beginning. And GitHub is strewn with better ways of doing things that were just never really properly evangelized because they're, you know, tailored to one person's use case, and maybe it just never really made sense to go out and try to persuade a whole bunch of other people that that was also their use case and that they should care about this better way of doing something. And that's fine, but there has to be a way forward if you're going to fix something that has become entrenched historically in this way. Programming languages, I think, are notoriously difficult to fix forward like this. So if I can ask a slightly inflammatory question, it's been since like 2008, I think. Like Python 3 has been out in the world for a while. How many people have used Python of any version? It's like maybe half the audience. How many of you have ever written Python 3 for like, yeah? Okay, that's 4 or 5 people. Okay, so why aren't people upgrading? Python 3 has a lot to recommend it. And, you know, to be fair, Python 2 is one of the most successful programming languages in the world. I don't want to dwell on this because this is not a Python conference. But Python 3 is a huge, huge step function. You have to accommodate a lot of very different ways of solving problems if you're going to upgrade to Python 3. And they do have a script called 2 to 3 that'll like convert the print keyword to a print function call, because that's some syntax that got more standardized. But that's not really what prevents people from switching. What prevents people from switching are like changes to the semantics of Unicode handling in Python, for which people have all of these existing sort of mostly working solutions that just aren't directly translatable to the new language. So that's why projects like Django, large projects, are probably not switching to Python 3 anytime soon, even though it is arguably a better language. So to bring it back to JavaScript, how can the next version of JavaScript, ECMAScript 6, avoid the Python 3 trap? And I have this crazy idea, which has not caught on, but I hope to persuade you all of it in the remainder of this, hope to persuade all of you of it in the remainder of this talk. The crazy idea is that we might be able to ease ourselves into the new version of the language with its new syntax and semantics by simulating its most useful features in the current version of JavaScript. And this is kind of an incredible idea, because what other language do you know of that has ever been responsible for ushering in its own next version, for self-hosting its own future? JavaScript is that language, and I think this sort of set of techniques is going to become quite common in the next couple of years. I'd like to call this linguistic time travel, because we're kind of reaching into the future and taking shiny things that we want right now and giving them to ourselves, whether or not native support has arrived yet. All right. So what's an example? Well, if you remember Jen Schiffer's talk, the very first talk from yesterday, where she pointed out if you call the built-in sort function on an array with no comparison function, then if your array consisted of numbers, they'll be turned into strings and sorted lexicographically. Well, if you want to avoid that, if you actually care about the numeric order of the array, then you definitely want to pass a callback function. And there is a new feature in ECMAScript 6 called arrow functions that makes this quite a bit more concise. So if you remember yesterday, the bottom is what you can do in JavaScript of today. You can pass a callback function with the function keyword, a and b as parameters, that returns a minus b, which sort of implicitly coerces a and b to numbers and then does numeric subtraction on them. But if you look at the top, we have this new syntax for writing these kind of throwaway callback functions, which doesn't require the return, doesn't require the function keyword, and if you care about whatever this was in the enclosing scope, automatically binds that callback function to this. We don't in this case, but and this example too is live editable, so I can change the names of things as much as I like. So another kind of transform is running in the background that's powered again by Recast, because what else would I use? Anyway, so this is pretty sweet. It shortens the code that you have to write, and it means that you often have to think less about binding this, since that's kind of a confusing feature of JavaScript for a lot of people. So how does this work? Well, it's a very similar routine to the previous example. I'm going to use a different tool for traversing and modifying the abstract syntax tree, just because I can, and it doesn't matter. Recast doesn't actually care how you do that, but everything else is the same, except for the code that we're parsing. So this traversal interface takes the root of the AST and then a callback function that gets called on every node. So we just need to check for every node, is it an arrow function expression? Well, if it is an arrow function expression, grab its body. And just in case the function has an expression body, meaning that its whole body is one expression rather than a block statement with potentially a return statement inside of it, we need to make that no longer the case, because that's also a new feature of ECMAScript 6, and turn expression functions into normal-looking functions with curly braces and return statements. And that's how we do that. And then we need to create a regular old function expression out of that arrow function expression, just sort of bring it into the present from the future. And just in case the value of this matters, we're making a call expression which calls the member expression consisting of our function expression and the bind method identifier, and passes this as the argument to that bind method. And that's all we need to do. We replace the current node with the new bound expression. And again, reprint the code by just calling recast.print with the AST, grab the little code property, and it prints out what we would expect. Cool. So if you already have a build step for your static resources, if you're running, Browserify, or have any opportunity to just put in an additional transform over your JavaScript, you can be cooking with arrow functions in a matter of minutes using Recast. Okay, so that's all well and good. And I love arrow functions as much as the next ECMAScript 6 enthusiast. But what about something a little more, a little trickier, a little more exciting that's coming in ECMAScript 6 and that you might have thought you had to wait for? Talking about, well, something that I'm personally quite excited about, generator functions. So a generator function is an idea that is borrowed, I guess, most directly from Python. In JavaScript, the syntax is that there's a little asterisk after the function keyword, and then you can use yield expressions. Yield is a new keyword that can occur in the bodies of these generator functions. And the way you would use this function, which prints out the Fibonacci sequence, is to call it, and that gives you back a generator object, and you can continually invoke the next method of that generator object, and that'll return a little record that has a value property and a done property. And the value is just whatever was most recently yielded. And the done property is Boolean, and it just tells you whether there are any more iterations to do. In all of the cases where value printed out a number, done was just false, but at the very end it's true. So we know to stop. Okay, so how would we go about taking this new syntax, which is definitely not legal JavaScript syntax, and translating it into JavaScript that you can run in a browser today? I mean, how hard could it be? So I tweeted this in May, I guess, of 2013, which seems quite a long time ago, I guess about a year ago, that I had been jokingly referring to this side project, sort of cryptically referring to a prototype version of Regenerator that I was then calling Degenerate, as my life's work. For so long, I was terrified it might actually be finished soon. And I was so wrong about that. It was not finished anytime soon after I tweeted that, so thank goodness I was not specific about what I thought I was about to finish. Anyway, it was the hardest code I've ever written, and I guess that says more about me than the problem at hand, but just to be honest with you, I wouldn't do it again. Actually, I would do it again. I know how to do it now, so it would be a lot easier this time around. Okay, so here is the same Fibonacci function with a little extra space to work with. As you can tell, translating to something that simulates a generator function in terms of current syntax expands the size of the code a bit. Okay, so what's the first step? Well, we're going to take all of our variable declarations and just move them to the top of the function. This is something that JavaScript already does. It's called variable hoisting. So this doesn't actually change anything. But now I just have var a, b, and next on the first line, and everywhere else that I previously had a variable declaration, it's just a variable assignment or an assignment expression now. And that might not seem like a big change, but it means that we can do the next step, which is to wrap everything except for that line of variable declarations in a generator function and make the outer function no longer be a generator function. You'll notice the asterisk has been removed from the outer Fibonacci function, and we're now returning an anonymous generator function. So it's, there's still generators here. There's still a yield expression that we have to deal with, but as you'll see in a second, the problem has actually become somewhat simpler, somewhat. All right, so we're going to rewrite this function, and how are we going to do that? Well, these generators are going to become little state machines that loop endlessly and switch on this property of a context object that I'll explain in a second that tells you which case of the switch statement to jump to. So these cases are like jump targets for go to, which you might consider harmful, but I consider pretty awesome. And so here's the first case that's just initializing those variables. I don't know why I thought the limit should be infinity. I guess that just makes it look cool. Okay, so then we intentionally fall through to case 3 here, and we check the condition of what used to be the while loop. And if that condition fails, then we're going to jump to the 11th case. And I think that's next. Yeah, the 11th case is in fact the very end of the function. That's where we're going to stop everything and bail out of this generator. But if the while loop condition succeeds, then we don't do that. And instead, we jump next to the 6th case, and we return A. And if you remember, we were yielding A in the generator function. So yield expressions have become return statements in JavaScript of today. So that's the sort of analogy to make here. All right, so you'll remember that we said we would resume at case number 6, and here it is. So we returned A, which bails out of this function, but then when we next call the next method of the generator object, the context.next will still be 6, so we'll jump directly to this case. And this is where we update the values of our variables so that next is the sum of A and B, A becomes B, B becomes next. And then what do? Well, we need to jump back to the beginning of the while loop, which was case 3. So basically setting context.next and then breaks out of the switch statement, but not the while loop. So we loop back for another iteration of the while loop and switch on whatever we just set context.next to. So that's how that works. Great. So we're literally almost done. There's one more thing to explain, though, which is where that context object comes from, because right now, sort of hand-wavy, magical sort of thing. And I will continue to wave my hands here, but there is a runtime function called wrap generator, which takes that anonymous function and turns it into a generator object, which is responsible for both creating the context object and making sure it gets passed in the same object to every invocation of this inner function. Cool. This final step's not actually all that interesting, although if you are wondering why that's necessary, I can go into that. Okay. So if you look at this code, there's nothing like futuristic about it. This is perfectly good ECMAScript 5 JavaScript of today. It's actually, I guess it's ECMAScript 4 or 3 too. There's nothing very complicated or magical about it. But it gives us all of the behavior that we ever wanted from generator functions, which is pretty freaking cool. All right, so what's the next step? Like, why do we care about generator functions? Well, asynchronous programming in JavaScript is difficult. It confuses a lot of people. And there's this idea, it was actually pioneered in C# of async functions and await expressions that has a very close analogy to generator functions. So regardless of how you feel about generator functions, I think you have to get excited about async functions because they're quite literally the sweetest syntactic sugar for asynchronous programming that you're likely ever to see. How do they work? Well, when you have a function expression or declaration, you can now, or you will in the future, be able to, the syntax is actually not standardized yet, so I'm conjecturing a bit here, but if you're following the C# example, you'll put the async keyword before your function keyword, and that'll mean that this function can now contain await expressions. So you'll see in the body of that for loop, we're awaiting each of the animations, which might complete asynchronously. And what does that mean? Well, it means that this chain animations function now returns, you guessed it, a promise. And so this is really just syntactic sugar over generators and promises. And it means that, like, if you're using jQuery, you can grab some card element and then pass a bunch of animations to it, maybe a flip that takes 100 milliseconds and a slide that takes 200 milliseconds. And then you can just wait for that to finish, because that's the promise syntax. And That's great, because like that's a relatively small amount of code there. And okay, so the great thing about this is that since we have a translation for generator functions and we have plenty of implementations of the promise spec, we can actually build support for async functions today. It's already built. I have a pull request. And it looks like this. It's very similar, if you remember the final slide of the generator translation, except instead of calling wrap generator directly, it's calling wrap generator async, which is going to be on the next slide. And then if you notice, we were awaiting animations sub I invoked against each element. And if you look at about the middle of this code, you'll see that we're returning that expression. And that's just because we basically translated that await expression into a yield expression and translated it the same way that we translate generators. So all that's left, I guess, is to define wrapGenerator.async. And I'm not going to go through this, but the thing that you should notice is that it's just using promises. It's returning a new promise, and it's using promise.resolve sort of towards the end. There's nothing complicated about this. This is just ECMAScript 5, or well, ECMAScript 5 with an implementation of promises, which are great because they can be straightforwardly implemented in JavaScript of today. There's nothing magical or ECMAScript 6y inherent about them. Yep, I have a pull request. Might as well just like open that up. It ended up being pretty straightforward. I added it to the Regenerator repository because it was just a little bit easier to incorporate that logic into something that was already translating generator functions. And so instead of just handling generators, we're now handling async functions. There's this function called rename await to yield that just traverses the body of the function and renames all the yield the await expressions to yield expressions. And then a couple of other slight differences, but that's you know, literally it. How many lines is that? There are a bunch of tests. That accounts for most of the 250 additional lines. So it's working. And the great thing about that is that we can sort of get a taste of the future and see exactly how bright it is and whether it's truly viable and is something that we want. And if it is indeed something that we desperately want, then we can start using it today rather than waiting for the slowest major browser vendor to implement it finally. So that's pretty cool. I hope I can go back to my slide. Yep, there it is. But wait. This was a talk about ECMAScript 6, which is the very next version of JavaScript. So when can we, expect native support for async functions and the await keyword? Well, that's not actually something that's planned for ECMAScript 6. I hope personally that it gets into ECMAScript 7, but it might not even make it into that version of the spec. So yeah, we're not talking about ECMAScript 6 anymore. And this raises an interesting specter that, I don't know, people who talk about transpiling code, taking features from the future of JavaScript and making them available today, I think often have this implicit assumption that that's something we're doing as a temporary stopgap, that we're just kind of bridging the distance between now and whenever ECMAScript 6 finally arrives. But I would argue that as long as there are shiny things even further in the future, we're going to be transpiling and taking those things from the future and bringing them to the present, and that's fine. We're always going to be transpiling, and this is a state of affairs that is only going to become more and more common in the next few years. So this kind of incremental transpilation, where we take individual features from the future of the language and give them to ourselves today, is, I think, the key to avoiding the Python 3 trap and the key to upgrading to future versions of JavaScript at a pace that makes sense at every step. It's how we bring about the future without choking on it, and it's how we know sooner rather than later how great the future will be. So, linguistic time travel. I'm excited about it. It's still really hard, though. Not everything can be transpiled. I don't really have a good story for how you might convert ECMAScript 6 symbols into ECMAScript 5, if you know about those. So we might just have to wait for native implementations. Abstract syntax tree transforms don't always play well together. Like, if you think about the relatively innocent step of inserting something as the first line of a function, like taking a rest parameter and calling array.prototype.slice.call is the first thing in the function, or maybe you want to translate destructuring function parameters, which is also something that sort of needs to happen before everything else in the function. Both of those transforms want to be the first thing that happens in the function, so which one wins? Well, you have to know something about both of the transforms in order to decide which order logically makes sense. So those kinds of coordination problems are actually really hard, and I don't know if they can be handled fully automatically. Niceties like source maps are just absolutely necessary when you're debugging this generated code, because it can get pretty far away from the source code, even if you're using something like Recast that tries to preserve original formatting. And the language specification can totally just change out from under you if you make the wrong bet on which direction it's heading in. So with those caveats, I will say that the JavaScript infrastructure team at Facebook is going to be working on this problem for as long as it takes to make the process of transpiling the future into the present as seamless as possible. It's all going to be open source, and you can help, because we're only just getting started.